Hi, I'm Bobo, Product Specialist at ThinkBox Software, and in the following demonstrations I want to show an existing feature of Krakatoa which can speed up your workflow when calculating particle flow with collisions. In this scene I have a simple plane with 25 by 20 segments, a noise modifier which creates something that looks like a terrain with 1000 polygons. There is a particle flow which was set to update once per frame and display 100% of all the particles. We are emitting 1000 particles from frame 0 to frame 30. We have a position icon which places the particles at the emitter, a force that is pulling them down with default settings, a collision using a universal deflector which uses the plane and a bounce coefficient of 0.7. and we're displaying the particles as yellow dots. If I play back with real time turned off, I'm going to get relatively usable frame rate of about 10 FPS, and the particles are bouncing around the geometry and falling down. If I select the plane and change its segments from 25 to 20 to, let's say, 100 to 100, this will increase the polygon count from 1000 to 20,000. And I can play back, and I'll notice that the performance after frame 30, when all 1000 particles have been emitted, will be down to approximately 1 FPS. Obviously, dragging the time slider interactively from left to right would be slow, and from right to left would be pretty much impossible, so it would require a cache operator in order to cache all the simulation data and allow interactive scrubbing. But each time you change something, you would have to wait for the cache to rebuild. Even worse, if we select particle flow and add 10,000 particles instead of 1000, and try to play back the same, we are going to get a very slow update. We are already under 1 FPS and the particles haven't even reached the bounding box of the geometry, and we haven't emitted all the particles. This shows that the collision test in 3ds Max is brute force and doesn't perform any optimizations. Even if the particles were a mile away from the geometry, they would still test each particle against each polygon of the geometry for potential collisions. The solution to this problem was introduced in Krakatoa 1.5 and is available as a bonus operator called Krakatoa collision test. This operator is enabled only in the commercial version of Krakatoa, and it's not enabled. It's visible, but it's not working in the free evaluation version. In order to use it, we're going to pick the geometry object, enter a magnitude of 70, which corresponds to the 0.7 bounce of the universal deflector. And if we play back again the same 20,000 polygons with the same 10,000 particles, we're going to get this performance. But you'll notice that some particles are actually leaking to the geometry. It means it's fast, but it's not very precise right now, and the reason for that is right now we are calculating with an integration step of 1 frame, and only 1 collision is being calculated by the operator per integration step. Instead of increasing the integration step, which would slow down all the other operators in the system, we can simply start increasing the max number of collisions, and if we do this, after about 4 or 5 collisions, you notice that there is no leaking anymore. In fact, we can enter 10 or 100 or 1000. This is the maximum number of collisions, but when a particle starts bouncing around within the integration step, it's going to perform only as many collisions as necessary before it stops colliding, so usually this number won't be reached. And if I play back now, you're going to see that it's actually performing nicely, and it's still very fast. So if we look at the FPS, it's running at around 30 FPS, which is pretty much real time. What would happen if we start increasing the geometry resolution again? Let's go to something like 500 by 500 polygons. This is 500,000 polygons with 10,000 particles. You notice that there is a little bit of processing which is caused by the rebuilding of the acceleration structure inside the operator. Once this was built, and if the geometry is not changing on each frame, we can press play and we get very similar performance. In this case we get 20 FPS instead of 30, but we're colliding against 500,000 polygons. We could go further. We can add 100,000 particles to be emitted. We'll have to remember that the drawing of the particles also has some influence. For a second I'm going to disable the display of the particles and just run a pure simulation. So you're going to see that the performance when all the particles have been emitted is around 3.3, around 3 FPS. And after most of the collisions have been processed, the performance might actually start going a little bit up here and there because less particles are close to the geometry and really colliding with it. If I enable the display, this will slow down things a bit, but still it will be faster than 1 FPS, and that's relatively useful for complex simulations where the collision is only a portion of it. Right now we're getting about 2.5 FPS instead of 3. Let's push this one to the limit, even though I wouldn't say that there is a real limit, but let's do 700 and versus 700 segments in the plane. This will give us nearly 1 million polygons. This will be 980,000 faces in the mesh. Again, there will be certain processing time once while the geometry cache is being built. Once the cache is there, as long as the geometry is not changing, the particles can perform collisions very, very fast. If the geometry is changing, there will be an obvious performance hit in rebuilding the acceleration structure, but still it will be faster than performing a test against each polygon, which in this case is 1 million of those. If I play back, you're going to see that the performance of the particles colliding with the geometry hasn't really changed much. We are still in the area of around 2 FPS. Slightly more even, 2.3 instead of 2.5 with 500,000 polygons. And the last thing that is left to try is add another 0 to the number of particles. Make sure that the number of particles is allowed. Yes, we have an upper limit that is much higher than this. And now we're going to emit 1 million particles against 1 million polygons, and it's still going to be approximately at around half FPS once all the particles have been emitted. If you remember, this was the performance with 10,000 particles against 20,000 polygons using the regular 3ds Max collision test. This means that we can get similar performance with 1 million particles and 1 million polygons as with orders of magnitude less with the original operator in particle flow. Once again, this is a feature that is available only in the commercial licensed version of Krakatoa and is disabled on purpose in the evaluation version of Krakatoa.